Ladies and gentlemen, this session will begin in about 5 minutes, so please begin moving to your seats to help us start on time. Thank you.
Ladies and gentlemen, please welcome to the stage Chief Warrant Officer 4, Tim Reyna, U.S. Army retired, Chief Information Officer, Chief Technology Officer, AFCEA International.
Good morning, everybody. Welcome back to this morning's mid-afternoon session. The next session that we'll be having this morning is titled Understanding the Division's Fight, Lessons Learned from the Tactical Edge. Our speaker, Major General Patrick Ellis, will be joining us virtually. Just a little bit of background about General Ellis. He received his commission in infantry after graduating from the United States Military Academy in 1994. Since then, he's had multiple deployments that include Operation Enduring Freedom, Operation Iraqi Freedom, and most recently led the cross-functional team at Army Futures Command. He assumed the command of the 4th Infantry Division at Fort Carson in June of last year. In welcoming
Awesome. I hope everybody can hear me. The hype music was going loud. So, hey, first off, just thanks to AFCEA and the team down at Augusta U.S. Army Cyber Command for hosting the event. And I'm sorry I couldn't make it down there in person. I have been to a couple of them now, and it's certainly a great event. I wish I was there in person to speak to you. Part of the reason I'm not is just got back from the National Training Center, and then really just got back from a bunch of commanders conferences and things. So we're getting geared up here to take NGC2 back into the Pacific now as part of it being a Pacific oriented unit. So we fly out on Sunday with NGC2 aboard a couple of C-17s and some Strykers as we fly into theater to start working on exercise called Garuda Shield there in Indonesia. So, folks really probably don't want to hear the history lesson on NGC2, but I probably need to give just a little bit of an update on kind of where we are and just to orient everybody. We did gain a ton of valuable insights at PCC6, and I, as promised in the tagline, I'll share some of those with you. I know a lot of industry teammates would be interested to hear that. To give you the history lesson where we are, 4ID just really recently finished our first year of prototyping. Really, I'd say it was about 10 months. I took over in June of last year, as the introduction said. But really, we didn't get hot and heavy into NGC2, starting the initial prototyping really until September. The approach we took here at the 4th Infantry Division was this. A lot of our brigades were gone. I had guys at the southern border, guys forward in CENTCOM. We were scattered around. Really, the DIVARTY and the division headquarters set the architecture, and then we worked on every iteration of pushing that. Every event we did, we pushed that down. I'll talk about the Sting series. We pushed that down lower and lower until it all kind of came together at PCC6. I would describe this on the back end of PCC6 when folks ask, what's the status of NGC2? I would say it's ready but not done, or I would say it's functional but not optimized. So we learned a lot of lessons. There's some things we need to continue to fix and things we need to continue to prepare, to repair. But I think we're in a good place now, and I'm looking forward to seeing where we can go over the next year. We were recently informed at the back end of PCC6 that, hey, we're going to carry this through and we'll run this through PCC7. However that looks, as we design that out, we're going to continue the same effort. And we're going to rerun some of the plays that we ran over the last year. We're going to rerun some of those as we build into to next year. To orient you real quick on NGC2, I usually talk about it a lot, and there's most folks there are relatively familiar with it. But it was the Army's whole stack approach to command and control modernization. It's like, hey, look, we had all these existing stovepipes. We had different systems. Each warfighting system had its own program of record. They had its own stovepipe data flows. Some of them even had their own transport. We had all this weird capability that was all gathered kind of in disparate ways, and to make those things work across those stovepipes was a significant undertaking for everybody. So about 2.5 years ago, General Rainey and Futures Command started leaning into this, saying, hey, what would be an industry approach to this? And a lot of the industry teammates, I think, helped the Army understand how to approach this problem. But it's a 4-tiered problem. And the way I would talk about it now, I'll start at the bottom, the transport layer. That's how you move the ones and zeros. That's how you communicate. That's where the radios live. That's where some of the data transmission devices live. That's all at the transport layer, moving the ones and zeros. The next layer up, I frequently call it the integration layer. I think that's something that the maneuver force understands better, but really it's also described as the infrastructure layer. That's the layer where all of the different feeds, the data, the disparate data, all kind of comes into one location. So it all feeds in. Some of it through cross-domain solutions, some of it's coming in through some of the stovepipes that still exist, some of that's coming in from the joint force. All that ends up in that infrastructure or integration layer, which then gets upgunned into the data layer, which is the third layer there. So one coherent data layer, all the data goes into one location. Now it's all in one place. And then on top of that, we've been able to build an application layer, and the application numbers have grown. I mean, I think we were at 8 for PCC 5. At PCC 6, I think we were in the 30s or 40s, I would say. That's split between IL6, the secret version, and IL5, the sensitive but unclassified version. And I think what we're seeing is, and as I talk about some general lessons learned from PCC 6, you'll hear, I think, that the applications were what the soldiers were looking for. And that's where we want most of the soldiers to spend their time, is in the application layer, not having to fight the data layer, or certainly not having to fight the transport layer, which has kind of been the history of communications and the reason why command and control has been kind of challenging for us. The approach we took to get us there to PCC 6, that was about a 10-month evolution, like I said. And the approach we took was we started hosting something called Ivy Sting series. It's actually an old fires exercise. We used to run one a year here in the division. We realized these were going to be great events for us to kind of ramp up. We did 5 iterations of that. So essentially every other month for 10 months, we did a Sting series. They started kind of small. I remember the first one was one data thread. It was some fire stuff, and it's like, oh, a data thread, just end to end. Can we make the ones and zeros move from end to end here as we do some data thread stuff? All the way up to Sting 5, where we were running multiple. We weren't even calling them threads at that point anymore. We were calling them, SDX lanes. We were calling them lanes, where we were doing casualty, fires, maneuver stuff, UAS integration. We were doing all of these different things. So it grew in scope and scale over the 10 months. In between each one of those, we also ran something we were calling solution summits. A lot of industry teammates have been invited to those. I'm sure there's folks there that are going to want to get invited to those. We have folks who are on the ground there. We can figure out for the right ones to bring people in. So we come together, usually starts with PT. It's kind of funny. We actually, the military guys from the division and the industry teammates are all invited to do PT out here. The numbers tend to decrease when it gets really cold, but we bring everybody out, we do a little PT, and then we spend the entire day together just kind of circling the drain on problems, saying, hey, look, here's an issue that we're having here at the 4th Infantry Division inside of NGC2. Hey, industry teammates, what do you have that can help? How can you contribute to helping us get ourselves better or to fix these problems? And those have been very beneficial. In fact, we've onboarded several vendors as a result of them participating in the solution summits to get us where we needed to do. To talk PCC 6 real quick, just really to kind of go by the scale of it, it was a large divisional rotation. So the way that it was organized is we had our Armor Brigade Combat Team, our Stryker Brigade Combat Team, our pieces of our Combat Aviation Brigade, pieces of our Division Sustainment Brigade, a multinational brigade, and then actually we had an additional battalion that we pulled in from one of the other formations. It was equipped a little bit differently. So it was about 8,900 people, like I said, allowed us to fight. If you're familiar with the National Training Center, the Northern Corridor, the Central Corridor, and the Southern Corridor all at once, west to east, and learn a ton of lessons there. The things that we saw, you talk to the OPFOR commander, I spent some time with him afterwards, 60% increase in the volume of fires that he saw. He doesn't exactly know why. I know why. I think a lot of it had to do with our ability to target, our ability to use the data more effectively. Saw a 60% increase in the volume of fires that he had coming at him. That was 30% by brigade. That's not just hey, because there's a division now, so the division crushed a bunch of that. Yeah, there was some of that, but I tell you that having the division enabling the fires flow there for us, I think was an effective way to approach this. Our processing time was down under 4 minutes per target, which was a pretty aggressive timeline for us. And the speed at which we were able to target was more effective. At the division level, I pay a lot of attention to that. That's part of my role, is to shape in front of the brigades, to get effects in front of those brigades. So that's what I was heavily focused on. And I think we did a decent job of doing that. And when you talk to the brigade commanders, they'll tell you they absolutely felt that effect. Also proliferated a lot of UAS, did some experimentation with the PCC technology. So just the kind of classic PCC 6 technology that you'd expect. while we were also fighting this stuff. So it's 24-hour operations, west to east. It wasn't a series of vignettes. We really started one into the box and fought all the way from west to east, and then turned and fought from north to south. And some of the adjustments we made in stride, I'm not so sure we could have done on the timeline or at the speed that we did without the enabling functions that came from NGC2. Here's some three big wins I would say that we felt on PCC6 that I'll share with you. One, I think true shared understanding. The data was the data. The blue dots were the blue dots. So you could see them at the end user device level. You could see them on the end user device. You could see them on the IL6 division level cop. So, we had the ability to filter this, but you could see them. So it's the same blue dot across all those domains. That's very useful. That's not something we were able to do beforehand. I think we had true shared understanding of where everybody was on the battlefield, which I think enabled us to be a little bit more effective when it came to making decisions as commanders, the brigade commanders and me, and also when we were trying to support the formation. I think the network resilience under load and under test, we found we weren't fighting the network. We were fighting with the network or fighting using the network a lot more, because what we found was a lot of the transmission and a lot of the software-defined networking capability was doing a lot of traffic routing on its own. So we weren't spending a lot of energy trying to figure out how to route the traffic. It was just kind of happening around us. In a relatively contested EW space, we just never really felt it. The OPFOR had a lot of capability they're trying to apply, and we just never really felt it. I mean, we had some ups and downs, but really it was never anything that was ever very permanent. And then on the flip side of that is we were able to hide in our own noise in most cases. There was never a command node at battalion level or greater that was found by the opposing forces in the EMS. So it was never found. Frustrated the OPFOR commander, is just not something he was able to do. And then I would say that the third benefit was the user-friendly data mesh, or the application layer. Everything was user-friendly. The soldiers found it to be, of course, I'm sure there'll be exceptions. You could find somebody who'd be frustrated by something, but the vast majority of this was the applications were easy to use, very intuitive. And because the soldiers had iterated on them, by the time they showed up down at the National Training Center, they were very familiar with how they were working. Three things I think that we need to continue to work. One, I would say optimizing the transport layer. As we scaled, as we went from running a couple of battalions, and we did an event here ahead of time where we ran one brigade and then really passed another brigade through them, but they were never really on the same spot with everything turned on in a spectrum contested environment, or in a spectrum limited environment, I should say. So when we turned on all the radios and connected everybody into the network down at PCC6, we had broadcast storms. We had a lot of traffic routing that was kind of counterintuitive. We were crushing our own networks, and the deal. If you choke off your SBUE side, your SIPR is running through that as a tunnel, so it starts crushing that as well. So we early on had some real challenges with optimizing the transport layer. I think we're in a much better place now, but I think there's still some more work to be done there. I'm super personally interested in private 5G. I think that's the way of the future. It allows us to really approach the commercial first side of this, using the commercial technology, decrease the number of high-end radios that we need, because in a lot of cases, soldiers just need a device that allows them to check a map, to see the blue dots, to see the red dots. We could do some of that stuff over private 5G, and I don't think we use that to its full potential. And then also tactical edge compute, which is another piece of what we brought with us. So we have, compute that you bring with you in the vehicles, in some cases dismounted, but it's, tactical edge compute. We would call these techs. How much of that do you actually need? And I think we may have over-indexed and taken too much of that with us. It's more about bringing a capability with you. I need ability to talk, to see blue dots, to see red dots, potentially to do some fire mission work, and maybe a little bit of rudimentary logistics. That's a capability. Those are capabilities I need. It's not about bringing reams and reams of data with every company commander forward. So I think those are the three ones that I would highlight for you. And then real quick, because it was promised to be, kind of the things I learned, I'd like to share with you 7 things that I learned. One, the tactical edge exposes what the lab cannot. Right. So you could have designed this in a lab and said, hey, this is a thing, and then brought it out for us to test. But the tactical edge, the volume, the scope and scale that I was talking about, 8,900 soldiers out there, everybody using Spectrum, all of the noise that was created with that, I think that exposed where we needed to get better. And it also allowed us to learn some things that we would not have learned any other way, other than actually scaling up and running that stuff at scale. I would say that I also learned that data only creates an advantage when it reaches the right decision maker at the right time. This is about making more, better, faster decisions. I felt like I, as a commander, had access because I was fighting 3 brigades and a combat aviation brigade. I had access to a lot more data. I had a lot more ability to understand what was going on the battlefield, not rely necessarily fully on pure reports. I could see some for myself. I could think it through. I could have the staff help me by wargaming that stuff using some of our modeling tools. And that allowed me to make better decisions on a lot more of them. And I think it allowed me to make them a lot faster. Although you'd have to talk to brigade commanders to feel their read on that one, I guess. I would tell you that I think that integration matters more than individual capability. So if we had one thing that was really, really great in one warfighting system, but if it didn't integrate or share data across, it wasn't super useful to us. I think that's something I found over the last year. Um, I would also say, number 4, that the network is a warfighting enabler, 100%, but it's also a vulnerability. So understanding how to protect that network, understanding how to use that network, and I think understanding how we're connecting. I think we have a better understanding of that now. Actually, we learned some lessons down there at PCC 6 that we're going to carry with us about how better to move our traffic around. I would say that commanders remain the critical node. We talk a lot about node-based command and control. Commanders remain the critical node. I think increasing commander options, reduced uncertainty, and what I think that allows us, that's what NGC2 allowed us to do. So it gave me more options. It decreased my uncertainty about the outcomes for those options, or really, the gray space of, do I need to wait to get more information to make a better decision? I was able to make decisions a lot faster. But what it didn't do is it didn't automate command. That's not how we're using this technology, and that's not what it's for. None of this stuff is going to replace the foundational warfighting tasks that are entrusted to a commander. And also, the technology is not an excuse for me. I own the responsibility. So if the technology is helping me make decisions, or there's a glitch in the technology, and I'm trusting that, then that still remains with me. I do think we weren't waiting for a prototype. So our training had to prototype along with us building out the technology, the prototyping, if that makes sense. So the way that we trained and the way that we fought adapted over time as we got increased access to the technology. I think there's a couple of different spins here. One thing we always say is like, look, let's use the technology to enable the existing staff functions, the mission analysis drills that we already do, like the things that we know how to do, we've done as an Army for years. Let the technology help us be better at those things and not replace those things with technology. And then there are some cases, and I'd say fires is probably one, where we figured out ways to use the technology to get even faster, and where it may change the way that we fight because we're so much faster. Our ability to target really quickly. Do we still need a separate counterfire headquarters, or can I do that stuff inside of my normal targeting because I'm just targeting at the same speed that we would have once upon a time? And I think that's what we're figuring out is important. And then the last one I would share with you is I think survivability must be designed in from the beginning. The tactical edge punishes overt signatures. It punishes large clusters of nodes. It punishes and comes after anybody who presents that kind of signature. We learned a lot of lessons about how to take command posts apart and scatter them and spread them. We adjusted the kind of the doctrinal way that we were fighting our nodes. So we basically took the rear, the main, the forward command post and took those things apart and reorganized them into much smaller nodes that we could then move around the battlefield. And we were moving relatively constantly. Every node jumped with it every 24 hours. And then inside of that, we also jumped, clusters of nodes to different locations on the battlefield based on the fight that we were seeing. So I'll wrap. I don't have a ton of time, but I'll wrap by saying 10 months, my perception of NGC2 here in the 4th Infantry Division was not perfected in a lab and delivered to the operational force. It was an iterative learning in conjunction with our industry teammates, our industry partners, with us here at the tactical edge. And I think the formation that fights with these kind of capabilities is going to be in best position to tell the Army, hey, this is working, this is not working. And we're sharing those lessons with the Army to make sure that the Army understands what we learned as the Army looks forward to making future decisions about how they're going to proceed with next generation command and control. And we're excited to see what the next year holds. With that, I'll pause. I think I've got like 2 minutes for questions.
We do have time for one question. How does NGC2 expedite the cyberkinetic kill chain timeline? And does NGC2 allow for the ability to make an accurate and informed decision to combatant commanders that's been vetted by SIGINT?
Yeah, so I don't want to get necessarily in the specifics of that, but what I would talk about is the targeting size, right? So combatant commanders is an interesting concept. Obviously, that's the very specific language. I would tell you at the division level, here's what it means for me with it when it comes to the kinetic kill chain. We have the ability now to use some of the data being in one location, to that tool, our ability to watch basically the data layer, to have tools and enable us to watch the data layer. When I list things out that are on my high payoff target list or on my division critical target list, things that I say are very important to the division, things that I want to destroy in front of the brigades, I can actually tell some of the tools to watch for that. And when they see something like that pop, to grab it and pull that in there, and then we can process that and run the fire missions relatively quickly. What that does for me as a commander is, instead of waiting for somebody to run a yellow sticky note across, or waiting for some analyst who's staring at an intel system to look at it and say, oh, I see something that's important, at least that I think is important, let me run this across and let me share this with the maneuver guys who are going to have to fire this mission. We're now actually all in the same data space. And so what we're doing is we're watching that data layer and having the tools help us watch that data layer. So when something new pops, we can grab that and run with it relatively quickly, and then run it through the entire kill chain. And because every effector is advertising its availability for tasking, if you think about what that means, is that now we have the ability to say, okay, it's not best sensor, best shooter. It's any sensor, any shooter. We look and say, okay, these are the tools that we need to apply to that. We can actually run those kill chains very quickly, because we're not having to make 1,000 phone calls. And I think something I'm also very proud of is our aerospace team has built a pretty powerful tool that's helping us deconflict and understand our airspace, which is another finite resource similar to Spectrum, and make decisions without having to make a lot of phone calls, to make a lot of decisions to push things down to say, oh, airspace is clear, we can shoot through that. We don't have to make a lot of calls to do that because we can see everything in the airspace. Hopefully that answers that question. Over.
Sure. That was our final question for General Ellis. Please welcome Tim Reyna back to the stage.
Can you hear me? Okay. General Ellis, thank you for sharing your thoughts and your time with us today. As an appreciation, FCA will make a donation to Signal and Cyber Museum Society on your behalf, sir. Ladies and gentlemen, we're moving to the next session of today's morning session is Next Generation Integration C2, Intel, and Fires in the Counter C2 Fight. I would like to welcome Steve Wagner, Vice President of Enlighten, to the stage to introduce the panel.
Good morning and welcome to today's panel. I'm Steve Wagner, as he said, President of Enlighten, an HII subsidiary. We're a proud supporting partner of AFCEA TechNet Augusta. For those not familiar with us, HII delivers advanced technologies and integrated solutions to support a modern multi-domain force. Our capabilities span big data processing and analytics at scale, comprehensive cyber platforms and operational tools, advanced EW engineering and expertise, and many other mission-critical technologies for defense and federal partners. Today, I have the honor of introducing our moderator for this session on behalf of AFCEA, Colonel Don Sedevi, Director of Transformation Integration for the United States Army Cyber Center of Excellence. Colonel Sedevi leads modernization efforts that shape the Army's future cyber, electronic warfare, and information advantage capabilities. He oversees cross-functional integration across Army and joint partners to accelerate next-generation technologies and strengthen readiness for multi-domain operations. Colonel Sedevi has held key leadership roles across operational units, joint commands, and strategic Army organizations, consistently championing innovation in operations, force design, and capability development. He's widely recognized for his ability to translate complex technical requirements into executable modernization pathways that enhance readiness and warfare effectiveness. It's an honor to have him here today, so please join me in welcoming Colonel Sedevi.
Moved too fast.
What's that?
Must I move too fast?
Yeah. All right.
All righty. Good morning, ladies and gentlemen. Thank you for attending our panel today. My name is Colonel Don Sedevi. Thank you for that wonderful introduction. I think most of that is true. That's a joke. I'm the Transformation Integration Director for the Cyber Center of Excellence, and it's my privilege to moderate today's panel discussion, Next-Gen Integration, Command and Control, Intel's Fires, and C2 in the counter C2 fight. To start off, let's establish our baseline. In an era of great power competition, dismantling an adversary's command and control architecture is not just a supporting effort. It's a foundational prerequisite for operational success. Against a peer adversary, if we cannot paralyze their decision-making networks, our physical assets will be outmaneuvered, disintegrated, and overwhelmed. The counter C2 fight is the fight that enables all others. To win this fight, we must face an uncomfortable truth, that our traditional siloed capabilities and linear operational planning are too slow. Historically, Intel has built the picture, passed it over the wall, and waited for fires to shoot the target. That paradigm is dead. Today, we're operating in degraded, disconnected, and denied environments. The target window to isolate an enemy commander or destroy a mobile C2 node has shrunk from hours to minutes. We require nothing short of deep, multi-domain convergence. That convergence relies upon the critical nexus of the network, intelligence, precision fires, and acquisitions. And that connective tissue binding them together is next-generation command and control, or NGC2. NGC2 is a fundamentally different approach from how we used to think about the network. It is not just about building a thicker pipe to push PowerPoint slides. Next-Gen C2 is a data-centric, transport-agnostic architecture. That means take whatever path you need to get there and just get the right data to the right place at the right time. As such, Next-Gen C2 is designed to take the deep sensing capabilities of the intelligence community and feed the right portions of the data directly into the lethal geometry of the fires community at machine speed. As a cyber officer, I view Next-Gen C2 as a synchronization engine. It allows us to visualize the adversary in time and space, layer non-kinetic disruption, binding the adversary digitally at a critical moment, and then execute kinetic strikes that destroy critical assets permanently in a single pane of data. It's how we guarantee overmatch. To dissect how we actually build and fight this architecture, we have senior leaders today who own portions of this problem set. You can read their full biographies in your programs. First, we have Colonel Tyler Donnell, PAE Fires Integrator, representing the fires community, tasked with executing lethal strikes and based on data. Next, we have Mr. Chris Manning on the far end, for the Capability Portfolio Executive for Intelligence and Spectrum Warfare, representing the intelligence warfighting function and the acquisitions community supporting Intel, who helps find the target in the noise. And lastly, we have Brigadier General Shane Taylor, the Capability Portfolio Executive for Command and Control Information Network, C2.